Our next collaboration-related talk goes into that, and we go into the world of blockchain. So this talk is a joint talk with Vendia. And from Vendia, we have the CEO of Vendia, Tim Wagner. And Vendia is focused at helping customers leverage data across companies, departments, and clouds. Tim also founded Serverless Tech, open source arm that fosters serverless innovation. In the past, Tim was VP of engineering at Coinbase. And before that, Tim worked at Amazon Web Services as GM of AWS Lambda, Amazon API Gateway, and AWS Serverless App Repository. Tim has a PhD in computer science from UC Berkeley. Welcome, Tim. Oh, you're starting? All right. So the talk will be started by my colleague in product management, Dave Huntley.
Hi, is this working? Yeah, sounds like it. Big green button, got it, okay. Yes, hi. Let's see, what have we got? Go past the disclaimer, all the mug shots, there we are. Yeah, so I'm Dave Huntley of Strategic Marketing and Business Development, also Standards Liaison at PDF Solutions. And as we've heard, Tim is the co-founder and CEO of Vendia. So the background for this talk is that PDF decided to take the initiative to explore whether we could improve or even deploy supply chain traceability by partnering with Vendia to combine our big data analytics with their blockchain technologies and experience. So today I'm going to talk a little bit about the market needs that we see and try to identify those, and then go and talk a little bit about the semi-traceability standards, which are part of the solution we're proposing. And then I'm going to hand it over to Tim, and he's going to carry on with the end-to-end approach to traceability and why we think blockchain is a good solution for that. So what is the market need? Well, first of all, there's a lot of cost involved in when things go wrong out there there's a lot of costs that can be reduced, first of all, and whether those costs are actually in dollar figures or in brand recognition and so forth, there are serious costs involved if you don't have traceability. I'm going to identify a few of those here. Reliability is the sort of obvious one. We are primed, obviously, to push towards zero defects, especially for automotive, auto-drive cars, and other applications like that. And if we don't learn from every single thing that happens out there, these very, very rare occasions when things go wrong, we need to learn from those every time they happen. Otherwise, we're never going to get rid of them. We're never going to be able to find the root cause. It's a very troubling statistic that about 50% of automotive recalls come back with the final answer that there's no root cause found. And that's just not okay. We're not going to ever get to zero defects if we can't. And the reason is the lack of traceability to go back and find the root cause. RMA is just the return field failures that get returned. It's always a very painful experience, but it's inevitable. But when it happens, you, as a manufacturer, you're going to want to do a very fast and precise response to reduce your costs, recall costs, and to protect your brand. Yeah, it seems like these automotive recalls are on these resurgence. So it seems from these links I've added in here. There's thousands of links about that support these points. I just added a few in this presentation. And then there's the security aspect. So by security, it means malicious, people maliciously attacking devices and putting Trojans, malware, etc. in. But it also, by security, we also mean counterfeits and grey market selling and so forth out there. So both of those basically compromise the quality and genealogy and provenance of the parts we're using in our critical infrastructure. Of course, the Department of Defense is the DoD supply chain is very sensitive to this. but so many others, other industries, consumer electronics, IoT, and pretty much all the electronics industry is sensitive to this problem. The costs are astronomical. Nobody will really admit to what they are, but they're huge. And so I haven't actually put a statistic up there other than the general statistic that apparently the 3.3% of world trade is actually fake. So that's a pretty big number. And a recent thing we've added is there seems to be a growing need for the regulations. There's a lot of the Export Administration regulations, the EARs, and other ones, and also international sanctions and so forth, which are becoming more and more prevalent, and we expect more and more of them to come with the current administration and going forward with this, the global challenges people face. So it's almost impossible to comply with these things without having a verifiable traceability of where your parts go and how they're used, etc. So if we had supply chain traceability, the promise of supply chain traceability is to be able to provide very fast, precise analysis of the event that took place, and then enable short-term and long-term containment, so you can reduce recall costs and so forth, and preserve your brand recognition as best you can, limit the damage basically, and ultimately to be able to provide parts which provide assurance that the parts we're selling are actually have the correct provenance and can be trusted. So we participated in an activity, a Global Semiconductor Alliance, which was the Trusted IoT Ecosystem Security, TIES they call it, and this was a consortium of many industry experts to try to collect the information together to try to figure out how we're going to address these problems in general. This is a bit of an eye chart, and I'm not going to go into it in detail, but it tries to describe the entire ecosystem we want to put together, from semiconductors through electronics throughout to the edge of IoT. Anyway, it talks about the trusted digital twins and analytics and so forth. As I say, there's just too much information on there, and anyway, it's too small. Probably nobody can see it anyway. But the point was that was a very useful initiative to try to bring together a lot of industry experts, and the result. This is actually the title of this slide, and the graphic itself came from the white paper, which was the output of that initiative that we participated in. So now I'm going to move on to some of the semi-standards that are involved in this. As John Kavarian mentioned in his first presentation yesterday, that PDF are focused on providing a sort of coherent data model across this end-to-end data model across the supply chain, and it should be standards-based. And so, in keeping with that standard-based approach, on behalf of PDF, I am the co-chair of the Advanced Backend Factory Integration Task Force, along with Brian Rubau from the Symmetrics Connectivity Group. And together, we are working on a number of things in improving standards for the back-end assembly area. But one of them is the E142 standard, which is defined substrate mapping. And and the E142 was initially envisioned to handle from wafer mapping to strip mapping and mapping of basically data onto products that we're making. But it turned into, because it actually records the transfer of devices from one thing to another, and it also allows you to associate and stamp on unique device IDs, whether they be an ECID or a PUF or any other sort of identifier you might want to put down, including, for example, the multi-beam mark that we talked was a presentation yesterday from multi-beam. That sort of thing, we can associate that with each individual device on any one of these things that we manufacture. It's a bit of an old-fashioned slide here, but we can model these wafer, any wafer, multi-project wafers, multi-chip packages on a strip, waffle packs, tape and reel. We can model that, and also the final printed circuit board, or even a more complex assembly. And all of these things can be represented in a coherent model, and you can associate data with it, including bin codes, transfers, device IDs, and other specifically device data. So it's single device. It's basically recording data at the single device level throughout assembly, and it's applicable from the very beginning to the very end, basically. This was published in 2006. I was part of the authors of that, and we revised it a few times, but most recently in 2021. We've currently got a ballot out there to improve it, to enhance it again, to add some implementation guidelines, so that it makes it easier to understand the standard and how to use it. Anyway, that's the E142, which has now been natively integrated into Exensio platform, and also the assembly operations piece. So there's a piece which talks to the factory floor, and there's a piece which talks to Exensio and uploads that data, but it's all compliant with this standard. I'm also the co-chair of the Single Device Tracking Task Force, and about 2019 we were working on a proposal, 6504, which was to put traceability on the blockchain. And so that's been around, this idea has been around for quite a long time. I just felt that SEMI wasn't a big enough place to have that conversation for the whole industry, because it extends beyond their mandate a little bit, even though they're a very important standards body at the beginning of the process. We went off and we had participated with the GSA TIES initiative, which is what that previous slide I showed came from there. And that was for some time. There's Tom Katsioulis is around somewhere. He was pushing that initiative at GSA, and it was very effective. And we generated a number of white papers, one of which had that graphic came from. But we've now got to a point where we're now ready to bring this back to SEMI. And so next month in November, we are firing up the Single Device Tracking Task Force again, and we're going to come back to this document. And this is basically the document which we're basing the partnership with Vendia on as well. So what this graphic shows is that you're basically tracking assets as they move through the supply chain. So once you've got an asset and you ship it out, you say, I'm shipping it. Well, first of all, you enroll it. So at birth, you enroll it like a wafer gets first created and the device is on it. And then you build things from it. You take those assets, you build them into bigger assets, and then you ship it to the next place on the supply chain and so forth. And each time you ship an asset, it contains a bill of materials. The bill of materials is an E142 representation of what is inside that asset and what assets it's linked to. So it provides a genealogy. So at the end of the day, when your circuit board fails out there or something goes bad, you can go back through the genealogy. You can explode the genealogy back and query all the supply chain nodes which were used to manufacture that specific part and ask them to say, hey, what happened here? And they will come back with a report. Report gets aggregated into a coherent, a complete report for the whole thing, and they can then utilize all the rich manufacturing data that's in the silos to reach the conclusions that they reach without giving away any of that data. So this is in the previous presenter was from AWS was talking about sharing data and so on to improve manufacturing and learn stuff, and that's a challenge, obviously. But we're saying that if in some cases, you just want to know the answer. What went wrong here? I need to do an RMA report. I need to go public with why this went wrong and what we're going to do differently about it. And you don't need to necessarily always have all the data there. And so that gives people a way to protect their intellectual property. Anyway, that's the whole idea of 6504. And if anybody's interested, by the way, to participate either in the ABFI task force on the 142 or in the Single Device Tracking task force on this 6504, please let me know, and I can get you signed up. We'd love to have. I'm sure there's some excellently well qualified participants here that we would love to have on those task forces. So to summarize, what we see that distributed ledger technology like blockchain is an important piece of a solution because it can be trusted, because it's decentralized, and because there's nobody particularly in control of it. So when you have partners who don't necessarily trust each other or don't want to, they can still participate in a consortium without actually, without worrying that they are being sort of snooped on. The NIST is PDF agree with NIST, and NIST has identified that this is an important technology we have to get figured out, and they've written a paper about it and submitted it to the administration. And so we're trying to be ready for that when that comes to fruition. We believe that this should be a standards-based solution because we want to include everybody in the supply chain, not just PDF customers. So we're playing nice in the industry for that, because we will continue to work with the SEMI and also with other standards bodies. So in that context, we started this partnership with Vendia, and to take advantage of their experience and expertise that they've already had in other industries with traceability on blockchain. And so this is what it looks like. We've got the PDF solutions with this whole array of products they have for analytics across the semiconductor product lifecycle, all the way from IC design, fab, sort, assembly, test, and the final system, all connected together with the DEX network. So that is the PDF world, that's what we've been here talking about. But we would like to add to that an underpinning of blockchain traceability, so that the actual analytics, the thing that actually reaches those conclusions of those reports, is going to happen inside an Exensio platform. But the sharing of the metadata, which allows you to get to that query, is going to be on the blockchain. That's the idea. So having said all that, I'm going to hand it over then to Tim from Vendia, and you'll take it from there. Hey, Tim. Oh, yeah. That's right.